Hello, everybody. Today we go for the 7.1. This one or the Z, we give out right here. We have this one or the Z. And so 7.1 confidence interval for mu, sig, for mu, but sigma is no. And um, as we know, this one, we can say the area critical, critical volume. So, the procedure, procedure is same thing, same the idea. So we have the bell shape. Uh, um, that is we can get right here. And so this one is we can say uh, we say this, we say this, and so this one is 1.64, and this one is 0.05. So as we know, so we can say this one is uh, so X bar. So this one is X bar. So this one is idea. And we go for the mute. And this one is pro. So this one mean. And this one is standard deviation mean. We go for that. So for this one, sigma. So this one is given. And also n is given. So we go with the um inverse norm. So we get area. Oh, we have area. So area is 0.5, mu is 0, sigma is 1. So we can have this example. Recent study of 36 taxi driver show that the average time they've been waiting for the customer is 65 minutes. If it's known that a standard deviation is 10 minutes. So 90% confidential interval for the true waiting for the time order for the taxi. We have to show for that. Is that true or not? So in here is N is 36. X bar, that is 65, and sigma, that is 10, and the alpha in here is 0.05. So step one. So we have alpha equal 1.65 0.95 because this one is 90%, because this one is 95%. So the whole thing is one minus for that, minus. So this one equals 0.05. So alpha over 2 is 0.05 over 2. So this one 0.025. So Z 0.025. And that is 1.6, 1.96 because we have right here. We already have right here. So step 2. So get E equal Z 0.025 sigma over square root of N. So E equal 1.96 times 10 over square root of 36. So this one is 3.27. So we have a step 3. So X bar plus and minus E equals 65 plus and minus 3.27. So we have step 4. Now step 4, X bar minus E less than mu less than X bar plus E. So this one is 65 minus 3.27 less than mu. So 65 plus 3.27. So we got, after calculation, we got 61.73 and mu as 68.27. So the conclusion, we are 95% confident that the true waiting time for a taxi driver. So in here, I can show you with the calculator. So we do the same thing. I can show with the calculator, it's the same thing. We go for start and we go for the test. So let me write out something in here on the side. So we will start and test. Okay, start test, and we go down to the 7. That is the interval. Okay, 7, the interval. And we go for input and start, and then sigma. So sigma in here, is 10, and the X bar is 65. So sigma start already, and then sigma is 10. X bar right here is 65, and N. So N is 36. So N is 36. And sea level. So sea level in here is right here, 0.95. So sea level 0.95 and calculate. So 0.95 and calculate. And we got right here 61, 78, and then 68, 27. That's right here. Okay. So we can do that. About for B, by the 99% upper true, 99% confidence interval for true waiting time for the taxi driver. So we have step one, alpha is mean 1 minus 0.99, and this one 0.01, and so alpha over 2, 0.01 divided by 2, we got 0.005. So z of 0.005. So we have right here z of 0.005 so over here. So that is 2.58. And step 2, E equal z 0.005 time for sigma over square root of n. So 2.58 times 10 over square root of 36 equal 4.3. So step 3. So x bar plus e. So we got 65 plus and minus 4.3. And step 4, x bar minus e mu and x bar plus e. And this one is x bar is 65 minus 4.3 mu and x bar plus 4.3. So we have 0.7 and this one mu. So this one 69.3. And for the calculation, as we do at the same as we done it before, we are 99% confidence that the true waiting time for our taxi driver is between 60.7 minutes and 69.3 minutes. Okay, so C, what happened for the C? What happened is the interval as the alpha gets the smaller, so explain. So we have the smaller alpha gets the bigger the interval. We can compare with that for this. This one 60 something, and this one, yeah, the interval. Um, so for in A, L4 is 0.05, so therefore 61.7 mil and 68.3 for B. Alpha is 0.01, that is 60.7 mil and 69.3. So as we know, this one is wider. So we can do same as the calculator. We can do same as the calculator. Okay. So we can do same as the calculator. So let me clear that. So we do start, hash, hash, and we go down to 7 Z intervals. To the 7, we can hit 7 right here, and 7 intervals, and we go to start. The bling bling. Let's go to start. So sigma is 10, and X bar is 65, N is 36, and C level point 0.099. So we have start and sigma 10, and this one is correct. And on a C level is 0.99 because we want to do this and enter for calculate. So we get this. So right here, and this one is right here. So that's how we get this. And then we can go for the next one. What is the sample? So we have Dr. V want to find out the average number hour for the students spent doing the mathematics homework per week. He considers the survey for 144 students. The average 7 hours standard for deviation is 2.5 hours long. So we can now export right here is 7. And then the sigma right here, so we got 2.5. And right here, N is 144. So step 1, step 2, step 3. So we can do it. So this one is alpha 1. So for A, find the 99% confidence interval for the real numbers of the hours that students study per week. So 1 minus 0.99, so this one 0.01. So alpha over 2, 0.01 over 2. This one is 0.005. So Z of 0.005. So we got 2.58, which we have right here. Okay, so we can do that. And right now we say E equal Z of alpha over 2 times sigma over square root of n. So it should be 2.85 and 12.5 over square root 144. So we got 0.5375. So now we can say x bar plus and minus. So x bar plus and minus e. So this one equals 7 plus and minus 0.5, 0.538. And then we have x bar minus e is mu x bar plus e. So 7 minus 0.538 mu and 7 plus 0.538. So we got 6.46 and mu and 7.54. So conclusion, we are 99% confidence that the true number of hours spent hour spent study 6.48 and 7.54 minutes. Oh, hours. Because this one we talk with the hours. Okay. And then for B, one claim that he study average 14 hours per week. Is that the reasonable? S is not reasonable. Is not in the interval. So 6.46 and 7.54. So how large for sample is need order for 2% image of 2. So now is one not arrow up 2. So up 2. So we can have this. So we know, as we know, sample size for that. So n equal z 0.005 and sigma over e square. So this one is 2.58, 2.5, and this one is 2. So this square. So this one approximately about 1.4. Oh, this one is we get 104,006.25. So this should be 104 0.007. So this one approximate about 10. Okay, that's all for 7.1.